November 21st, 1944, 32,000 feet above the Kanto Plain, Lieutenant Colonel Robert Morgan levels his B-29 Superfortress, christened Dauntless Dottie, and begins the bombing run that should be impossible. Behind him, 110 identical aircraft maintain formation, their silver fuselages catching the morning sun like a river of metal flowing across the sky. Below, Tokyo spreads in every direction, its factories humming with war production, its citizens unaware that American bombers have just traversed an ocean. The Japanese fighter pilots scrambling from Chofu Airfield cannot comprehend what they're seeing. These aircraft have flown from the Mariana Islands, 1,500 miles of open Pacific, carrying 5 tons of bombs each, and they still have fuel to return home. The duty officer at Tokyo's Air Defense Headquarters transmits an urgent message to Imperial General Headquarters. Enemy bombers attacking from an impossible distance. Request verification of enemy base locations. The response comes within minutes, tinged with disbelief bordering on panic. No American bases exist within bomber range of the home islands. Repeat, no bases exist. But the bombs falling on the Musashino aircraft engine plant are very real. The thunder shaking windows across Tokyo is very real. And the silver stream of B-29 seconds turning south for their return journey is undeniably real. Japanese commanders faced an equation that shattered everything they understood about strategic warfare. American bombers had just demonstrated a combat radius that exceeded the distance from Berlin to Moscow, from London to Baghdad, from any point in history where aircraft had struck an enemy homeland. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. How had America built a machine that could fly farther than Japanese planners thought physically possible? And why had Japan's military leadership so catastrophically miscalculated the industrial and technological gulf that separated their empire from the nation they had attacked at Pearl Harbor? The answer begins not with engineering triumph, but with strategic blindness, a blindness that would cost Japan everything. 3 years earlier, in the winter of 1941, Japanese naval intelligence had completed the most comprehensive assessment of American bomber capabilities ever conducted by a foreign power. The report, delivered to Admiral Isoroku Yamamoto and the Imperial Navy's General Staff, contained calculations that would define Japan's defensive strategy for the entire war, and every single calculation was catastrophically wrong. Lieutenant Commander Suguru Suzuki, the Navy's chief aviation analyst, had studied American bomber development with meticulous attention. He knew the specifications of every aircraft in the Army Air Corps inventory. The B-17 Flying Fortress, maximum range 2,000 miles, combat radius 800 miles. The B-24 Liberator, maximum range 2,800 miles, combat radius 1,000 miles. These were formidable machines, capable of striking deep into enemy territory from forward bases. But Suzuki's analysis contained a fatal assumption that would doom Japanese strategic planning. He calculated bomber range based on maximum fuel capacity divided by consumption rates at optimal cruising altitude. His mathematics were flawless. His understanding of American industrial philosophy was non-existent. Japanese bombers, exemplified by the Mitsubishi G4M, Betty, achieved their impressive range through a design philosophy that sacrificed everything for distance. No armor plating protected the crew. No self-sealing fuel tanks prevented catastrophic fires. The aircraft's aluminum skin was so thin that machine gun bullets passed through without detonating. American pilots called them flying Zippos because they ignited so readily. This design approach made perfect sense within Japanese military doctrine. Bushido philosophy emphasized offensive spirit over defensive preparation. A warrior who expected to be hit had already accepted defeat. Therefore, Japanese aircraft were built to strike first and strike hard, accepting vulnerability as the price of range and speed. Suzuki assumed American bombers followed identical logic. He calculated that any aircraft capable of reaching Japan from potential forward bases would necessarily sacrifice armor, defensive armament, and payload capacity. Such bombers would be vulnerable to fighter interception and unable to inflict strategically significant damage. His report concluded with mathematical certainty: American bomber forces pose no threat to the home islands provided our defensive perimeter remains intact. Admiral Yamamoto read this assessment with profound relief. Japan's strategy for the Pacific War depended on establishing a defensive barrier stretching from the Aleutians through the Central Pacific to the Dutch East Indies. Within this perimeter, Japan would consolidate its conquests and build an empire too costly for America to assault. If American bombers lacked the range to strike Japanese industry, then time favored the emperor's forces. The assumption was shared across all levels of Japanese military planning. General Hideki Tojo, commanding the Imperial Army, had received similar intelligence from his own aviation experts. Army analysts calculated that the nearest point from which American heavy bombers could theoretically reach Tokyo was Attu Island in the Aleutians, requiring a round trip of 3,000 miles. No existing bomber could carry meaningful bomb loads across such distances. Therefore, Japan's air defense infrastructure was designed to counter tactical threats, not strategic bombardment. Fighter squadrons were positioned to intercept carrier-based aircraft with ranges of a few hundred miles. Anti-aircraft artillery was concentrated around ports and military installations, not industrial centers. Early warning radar, still primitive by American standards, was calibrated to detect formations approaching from nearby bases. The flaw in this logic would not become apparent until American submarines and codebreakers revealed the true nature of Japanese defensive preparations. By then, Boeing Aircraft Company in Seattle was already building something that would make Japanese calculations irrelevant. The B-29 Superfortress existed because one man refused to accept the limitations that defined contemporary bomber design. In 1938, General Henry Hap Arnold, commanding the Army Air Corps, had studied Japanese expansion in China and drawn conclusions that his superiors dismissed as alarmist fantasy. Arnold believed that future wars would be decided not by armies clashing at borders, but by industrial production destroyed from the air. This vision required a bomber unlike anything that had ever flown. It would need to carry 10,000 pounds of bombs across distances exceeding 3,000 miles, fly at altitudes beyond the effective ceiling of enemy fighters, and defend itself with firepower that could destroy attacking aircraft before they closed to lethal range. Most critically, it would need to accomplish all this while protecting its crew behind armor plate and self-sealing fuel tanks. The engineering requirements seemed impossible. Contemporary aircraft design accepted fundamental trade-offs: range versus payload, altitude versus speed, defensive armament versus weight. Arnold was demanding an aircraft that refused every compromise, that somehow transcended the physical laws governing flight. Boeing's chief engineer, Edward Wells, understood that conventional design approaches would fail. The B-29 would require innovations in every system simultaneously: engines, aerodynamics, pressurization, defensive armament, even the manufacturing processes that would build it. The technical challenges were so severe that Boeing's initial proposal predicted a development timeline of 7 years and a unit cost 3 times that of existing bombers. The Army Air Corps awarded the contract anyway. In 1939, with war already consuming Europe and Asia, America committed to building a bomber that existed only as calculations and drawings. The gamble was immense. If the B-29 failed, the United States would have spent hundreds of millions of dollars on an aircraft that couldn't perform its mission. If it succeeded, American bombers would reach any target on Earth. The Wright R-3350 Cyclone engine represented the technological heart of the B-29's unprecedented range. Each Superfortress would carry 4 of these radial power plants, each producing 2,200 horsepower from 18 cylinders, displacing 3,350 cubic inches. The engines were mechanical marvels, incorporating technologies that pushed American metallurgy and precision manufacturing to their absolute limits. But the R-3350 was also a nightmare that nearly destroyed the entire program. During initial testing in 1942, the engines caught fire with terrifying regularity. Cylinder heads cracked under thermal stress, connecting rods shattered, sending piston fragments through crankcase walls. Oil temperatures exceeded safe operating limits within minutes of takeoff. Test pilots reported that flying the early B-29 seconds felt like riding a bomb that could explode at any moment. The problem was fundamental to the engine's design. To produce sufficient power for the B-29's weight and performance requirements, the R-3350 operated at cylinder pressures and temperatures that exceeded anything attempted in previous radial engines. The aluminum alloys used in the cylinder heads could barely withstand the thermal cycling between ground idle and maximum power. The magnesium crankcase, chosen for its light weight, was prone to catastrophic failure when internal components failed. Boeing engineers worked desperately to solve problems that threatened to cancel the program entirely. They redesigned the cooling baffles that directed airflow around the cylinders. They modified the fuel injection system to prevent hot spots in the combustion chambers. They added additional oil coolers and revised the engine mounting structure to reduce vibration. Each fix solved one problem while creating others. The improved cooling baffles increased drag, reducing maximum speed. The modified fuel injection required higher octane gasoline, complicating logistics. The reinforced engine mounts added weight, decreasing range. The B-29 was becoming heavier, slower, and more complex with each engineering iteration. General Arnold, watching development costs spiral upward while delivery schedules slipped further behind, made a decision that horrified conservative military planners. He ordered the B-29 into full production before flight testing was complete. Boeing would manufacture hundreds of aircraft while simultaneously solving the technical problems that made those aircraft dangerous to fly. It was industrial madness, a gamble that risked not just money but the lives of crews who would fly unproven machines into combat. The decision was driven by intelligence that was filtering back from the Pacific. Japanese forces had captured the Philippines, Malaya, and the Dutch East Indies with shocking speed. Their defensive perimeter now stretched 5,000 miles from the home islands, far beyond the range of any existing American bomber. If the B-29 program failed, Japan's industrial heartland would remain invulnerable until American ground forces fought their way across the Pacific, island by bloody island. By mid-1943, Boeing's Seattle and Wichita factories were producing B-29 seconds faster than test pilots could identify and document their flaws. Each aircraft that rolled off the production line represented $2 million and 60,000 man-hours of labor. Each aircraft also represented dozens of unresolved technical problems that would need to be fixed in the field by maintenance crews who were learning the Superfortress's systems as they worked. The firepower that bristled from the B-29's fuselage represented another revolutionary innovation. Previous American bombers defended themselves with manually aimed 50-caliber machine guns, each operated by a dedicated gunner who aimed by eye and fired by instinct. This system worked adequately against fighters attacking from predictable angles, but it was hopelessly inadequate against the diving and climbing attacks that German and Japanese pilots had perfected. The B-29 introduced a concept that seemed like science fiction: remote-controlled gun turrets aimed by sophisticated computing systems. Each gunner sat in a pressurized compartment, looking through a transparent sighting station while controlling turrets located elsewhere on the aircraft. The central fire control system could coordinate multiple turrets against a single target, concentrating firepower in ways that manual gunnery could never achieve. The technical implementation required innovations in miniaturized hydraulics, electrical servo systems, and analog computing. Each sighting station contained a mechanical computer that calculated bullet trajectory based on airspeed, altitude, target range, and deflection angle. The system worked so quickly that gunners could track and engage fighters, making 400-mile-per-hour attack runs with accuracy that seemed impossible. Japanese fighter pilots, accustomed to attacking American bombers from angles that minimized defensive fire, would discover that the B-29 had no blind spots. Every approach vector was covered by multiple turrets controlled by gunners who could engage targets before they entered effective range. The Superfortress carried 12 50-caliber machine guns and one 20mm cannon, all capable of firing simultaneously at any attacker foolish enough to press an attack. But the feature that truly enabled the B-29's unprecedented range was invisible from outside the aircraft. The pressurized cabin, maintaining sea-level atmospheric pressure at altitudes above 30,000 feet, allowed crews to operate effectively for the 10 to 15 hours required for missions deep into Japanese-held territory. Previous bombers required crews to wear oxygen masks and heated flight suits, fighting against cold and hypoxia throughout their missions. The physical and mental exhaustion degraded performance and limited mission duration. The B-29's pressurization system transformed long-range bombing from an endurance test into a sustainable operation. Crews could eat hot meals, move freely through the forward cabin, and maintain mental alertness throughout missions that would have been impossible in unpressurized aircraft. The system added weight and complexity, but it multiplied crew effectiveness by factors that more than compensated for the engineering trade-offs. By spring of 1944, the first combat-ready B-29 seconds were arriving at forward bases in India and China. The aircraft that Japanese intelligence had calculated could not exist was about to demonstrate capabilities that would shatter every assumption about strategic warfare. The Superfortress was coming, and it would arrive from distances that Japanese commanders still believed impossible. The first combat mission of the B-29 Superfortress against Japan was launched not from the carefully calculated perimeters of Japanese defensive planning, but from a location so remote that it seemed designed to mock the very concept of strategic bombing. On June 15, 1944, 92 B-29 seconds lifted off from primitive airfields near Chengdu, China, bound for the Imperial Iron and Steel Works at Yawata on the Japanese island of Kyushu. The mission was a logistical absurdity that could only have been conceived by minds desperate to strike Japan before conventional island-hopping campaigns brought bombers within reasonable range. The B-29 seconds in China were supplied entirely by air, with every gallon of fuel, every bomb, every spare part flown over the Himalayan mountains from India in a supply chain that consumed 6 tons of fuel to deliver 1 ton of bombs to Japanese targets. General Curtis LeMay, who would later command all B-29 operations against Japan, he called it the most inefficient use of strategic air power in military history. Yet it achieved something that no amount of efficiency could calculate. It demonstrated to Japanese commanders that American bombers could reach the home islands from any direction, from distances that made defensive planning meaningless. The reaction at Imperial General Headquarters in Tokyo was not panic, but confusion bordering on denial. When the first reports arrived describing American heavy bombers over Kyushu, staff officers immediately questioned the identification. Perhaps these were captured Japanese bombers being used in some elaborate deception. Perhaps they were actually launched from carriers in a replay of the Doolittle raid. Colonel Takushiro Hattori, operations chief for the Imperial Army, demanded verification of the aircraft type, their approach vector, and most critically, their point of origin. The answers, when they arrived, defied military logic. The bombers were definitely B-29 seconds, distinctive with their high aspect ratio wings and cylindrical fuselages. They had approached from the west, from the direction of China, and they had carried sufficient fuel and ordnance to conduct sustained bombing runs before returning to bases over 1,000 miles away. Hattori's response was recorded in his staff journal with a notation that revealed the depth of Japanese miscalculation. Enemy bomber performance exceeds all intelligence estimates by factor of 2. Recommend immediate revision of defensive perimeter doctrine. But revising doctrine required acknowledging that the war's fundamental assumptions were wrong. Japan had attacked Pearl Harbor, believing that American industrial power, while vast, could not be effectively projected across the Pacific's immense distances. The defensive perimeter was designed to keep American forces at arm's length until negotiated peace became preferable to the cost of island assaults. The B-29 demolished this strategy by reaching over the perimeter without needing to break through it. Japanese fighter squadrons positioned to intercept attacks from forward bases were useless against bombers operating from China. Anti-aircraft batteries sited to defend against tactical strikes from carriers could not engage aircraft flying at altitudes beyond their effective ceiling. Early warning systems calibrated for short-range threats provided insufficient time to scramble interceptors against raids developing from 1,000 miles away. The military implications were catastrophic, but the psychological impact was worse. Japanese propaganda had assured the population that the home islands were invulnerable, protected by distance and by the martial spirit of defenders who would never allow enemy aircraft to violate sacred airspace. The B-29 seconds proved this was fantasy. American bombers could strike anywhere, anytime, from bases that Japan lacked the resources to attack. Admiral Soemu Toyoda, who had replaced Yamamoto as commander of the combined fleet, convened an emergency conference to assess the threat. His staff presented calculations that should have been prepared years earlier, analyzing American bomber capabilities based on observed performance rather than theoretical assumptions. The numbers were devastating. The B-29 demonstrated a combat radius of 1,500 miles while carrying 5 tons of ordnance. This meant that once American forces captured islands in the Marianas, particularly Saipan and Tinian, every city in Japan would be within range. Tokyo, Osaka, Nagoya, Kobe, all of Japan's industrial heartland would be vulnerable to sustained strategic bombardment. Toyoda understood naval warfare with profound sophistication, but he grasped immediately that the B-29 had transformed the Pacific conflict into something beyond naval campaigns. "We are no longer fighting a war of fleets and armies," he told his staff. "We are fighting a war of industrial capacity, and in that war, we have already lost." The fall of Saipan in July 1944 confirmed Toyoda's analysis with brutal clarity. American engineers immediately began constructing airfields that would host hundreds of B-29 seconds. Unlike the improvised bases in China, the Marianas facilities would have paved runways, proper maintenance hangars, dedicated fuel storage, and bomb dumps supplied by cargo ships that arrived weekly with thousands of tons of ordnance. Japanese reconnaissance aircraft photographed the construction with growing horror. The Americans were building not just airfields, but entire industrial complexes designed to support a bombing campaign of unprecedented scale. Intelligence analysts counted 6 parallel runways on Saipan, each over 8,000 feet long, capable of launching 2 B-29 seconds per minute. Similar facilities were under construction on Tinian and Guam. By October 1944, the first B-29 seconds began arriving in the Marianas. They flew directly from California, a journey of over 6,000 miles, demonstrating range capabilities that Japanese planners still struggled to accept. Each aircraft represented American industrial might concentrated into a single weapons system: engines built in New Jersey, propellers from Ohio, electronics from Massachusetts, airframes from Kansas and Washington, all assembled into machines that could reach across an ocean to destroy the factories that built Japanese warplanes. Lieutenant General Torashiro Kawabe, responsible for the air defense of the home islands, possessed perhaps the clearest understanding of Japan's predicament. He had studied at the Army War College before the war and had access to intelligence about American industrial production. The numbers told a story that military tradition refused to acknowledge. American factories were producing B-29 seconds at a rate of over 100 per month. Each aircraft cost approximately $600,000, a sum that would buy 30 Japanese fighters, but those 30 fighters would need fuel, ammunition, trained pilots, and bases from which to operate. Japan's industrial capacity was collapsing under submarine blockade and previous bombing campaigns. Fuel production had dropped to a fraction of wartime requirements. Pilot training had been shortened from years to months, producing aviators who could barely fly, much less engage American bombers at 30,000 feet. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Kawabe calculated that Japan would need to shoot down 5 B-29 seconds for every one the Americans lost to make strategic bombing unsustainable. Given American production rates, this meant destroying over 500 superfortresses per month while replacing Japan's own fighter losses. The mathematics were impossible. Even if Japanese pilots achieved unprecedented kill ratios, American industrial capacity would overwhelm Japanese defenses through sheer numerical superiority. The first major raid from the Marianas struck Tokyo on November 24, 1944. 111 B-29 seconds participated in the mission that opened this narrative, marking the beginning of a campaign that would systematically destroy Japan's ability to wage war. The formation departed Saipan in early morning darkness, each aircraft carrying 5 tons of high-explosive bombs aimed at the Musashino aircraft engine plant. The Japanese response demonstrated both the determination and futility that would characterize home defense efforts for the remainder of the war. Fighter squadrons scrambled from airfields throughout the Kanto region, their pilots prepared to sacrifice themselves against the American formation. But the B-29 seconds flew at altitudes where Japanese fighters could barely operate. The Ki-84 Hayate and Ki-61 Hien, Japan's best interceptors, could reach 30,000 feet only by stripping away armor and ammunition, reducing themselves to nearly defenseless platforms. Those pilots who managed to reach the bomber stream discovered that the B-29's defensive armament was even more formidable than intelligence reports had indicated. The remote-controlled turrets tracked approaching fighters with mechanical precision, concentrating fire from multiple guns on single targets. Japanese pilots, accustomed to attacking American bombers from below, found that the B-29's ventral turret covered this traditional blind spot with devastating effectiveness. Sergeant Isamu Sasaki, flying a Hayate fighter from Chofu Airfield, later described his first engagement with the B-29 formation in terms that revealed the technological gulf between the forces. "I approached from the sun, diving to build speed for my attack run," he wrote in his combat report. "Before I entered firing range, tracers from multiple turrets converged on my aircraft. The Americans were shooting from over 800 meters, distances where our own guns were ineffective. I broke off the attack after my wingman's fighter disintegrated under concentrated fire. We shot down nothing. They destroyed 3 of our aircraft." The pattern repeated throughout the engagement. Japanese fighters made determined attacks, pressing through defensive fire with courage that bordered on suicidal. A few managed to close to effective range and damage individual bombers, but the kill ratio favored the Americans overwhelmingly. 3 B-29 seconds were lost to all causes during the mission. The Japanese lost 18 fighters, and the bomber formation reached its target and returned safely to the Marianas. The bombing results were less impressive than the demonstration of strategic reach. High-altitude precision bombing proved difficult, even with the B-29's sophisticated Norden bomb sight. Only 24 aircraft actually dropped their ordnance on the primary target, while the remainder bombed alternate objectives or scattered their loads across Tokyo's urban area. The Musashino plant sustained minor damage and resumed full production within a week, but from a strategic perspective, the damage assessment was irrelevant. The mission proved that American bombers could strike Japan repeatedly, systematically, from bases that were invulnerable to Japanese counterattack. Each raid would destroy some portion of Japanese industrial capacity, kill some number of workers, disrupt some element of war production. The cumulative effect would be measured not in single missions but in months of sustained bombardment. General Kawabe submitted a memorandum to the Army High Command that was remarkable for its brutal honesty. "The appearance of B-29 seconds over the home islands represents fundamental strategic defeat," he wrote. "We lack the fighters to intercept them, the fuel to maintain continuous patrols, the radar to provide adequate warning, and the anti-aircraft artillery to engage them at altitude. Most critically, we lack the industrial capacity to build the defenses we need faster than American bombers can destroy our factories." His recommendation was equally stark. "The war cannot be won through defensive measures. We must seek negotiated peace while we retain the capacity to inflict casualties that make invasion unacceptable." The memorandum was filed without action. Japanese military doctrine had no framework for acknowledging defeat while forces remained in the field. The war would continue until every aircraft was destroyed, every pilot killed, every city burned. The B-29 seconds would continue their missions, and Japanese defenders would continue their futile resistance, knowing the outcome was predetermined by mathematics that no amount of courage could alter. The transformation of B-29 operations from high-altitude precision bombing to low-altitude incendiary attacks represented the final shattering of Japanese assumptions about American strategic doctrine. In March 1945, General Curtis LeMay made a decision that shocked his own staff. The superfortresses would abandon their technological advantages and attack Tokyo at night, flying at altitudes between 5,000 and 8,000 feet, stripped of most defensive armament to maximize bomb load. The reasoning was coldly mathematical. High-altitude precision bombing had failed to achieve the destruction rates necessary to cripple Japanese war production. The jet stream winds at 30,000 feet scattered bomb patterns across miles of territory. Cloud cover obscured targets for weeks at a time. Japanese industry, dispersed into thousands of small workshops throughout urban areas, was nearly impossible to destroy with pinpoint strikes against individual factories. But Japanese cities themselves were vulnerable in ways that American planners had been slow to recognize. Construction was predominantly wood and paper, designed to withstand earthquakes rather than fire. Structures were packed densely in urban cores, where fire departments lacked the water pressure and equipment to combat large-scale blazes. Most critically, Japanese air defenses had been optimized for high-altitude interception and were largely ineffective against low-flying aircraft at night. LeMay's plan called for B-29 seconds to attack in streams rather than formations, each aircraft finding its own path to the target while dropping incendiary clusters designed to start thousands of individual fires that would merge into unstoppable conflagrations. The superfortresses would carry 9 tons of ordnance instead of 5, made possible by removing guns, ammunition, and gunners that were no longer needed. His staff officers protested that the plan violated everything the B-29 program had been designed to achieve. The superfortress's pressurization, defensive armament, and high-altitude capability would be abandoned in favor of tactics that any conventional bomber could execute. LeMay's response revealed his understanding of strategic bombing's true purpose. "We're not here to demonstrate technology. We're here to destroy Japan's ability to make war. If that requires flying at 5,000 feet with incendiaries, then that's what we'll do." The first firebombing raid struck Tokyo on the night of March 9, 1945. 334 B-29 seconds participated in an attack that would become the single most destructive air raid in human history. The bombers arrived over Tokyo after midnight, their silver fuselages painted black to reduce visibility in searchlight beams. Pathfinder aircraft marked the target area with napalm clusters that burned bright enough to guide following waves from 50 miles away. What happened over the next 3 hours was not warfare, but systematic destruction on a scale that defied comprehension. The incendiary clusters, each containing dozens of individual bomblets filled with jellied gasoline, ignited thousands of fires across a 16-square-mile area. The fires merged as LeMay had predicted, creating a conflagration that generated its own weather system. Superheated air rose in massive columns, creating ground-level winds that reached hurricane force and fed flames that consumed everything combustible. Tokyo's civil defense preparations, adequate for conventional bombing, were utterly overwhelmed. Firefighters who attempted to combat the blazes were incinerated when wind-driven flames jumped fire breaks that should have been impassable. Citizens who fled into canals and rivers drowned when masses of refugees pushed them underwater or were boiled alive as the water itself heated beyond survivability. Those who remained in shelters died from carbon monoxide poisoning or heat stroke as the firestorm consumed the oxygen from the air itself. Captain Masatake Okumiya, a staff officer at Naval Air Force Headquarters in Tokyo, witnessed the attack from a shelter near the Imperial Palace. His description, recorded immediately after the raid, captured the apocalyptic scale of destruction. The fires were not separate blazes, but a single ocean of flame that stretched to every horizon. The sound was not explosions, but a continuous roar like an enormous waterfall. The heat was so intense that concrete buildings burst into flame spontaneously. I understood then that we were not fighting a war but witnessing the destruction of our civilization. By dawn, 16 square miles of Tokyo had been reduced to ash and twisted metal. Official casualty figures estimated 88,000 dead and 41,000 injured, though actual numbers were certainly higher. Over 1 million people were homeless. The industrial capacity destroyed in a single night exceeded the cumulative damage from all previous B-29 raids combined. Japanese commanders could no longer deny the reality that confronted them. The B-29's range had rendered Japan's defensive perimeter meaningless. The Superfortress's payload capacity meant that even small formations could inflict catastrophic damage. Most critically, American willingness to adopt incendiary tactics demonstrated that the United States would accept no outcome short of Japan's complete destruction. Admiral Kantaro Suzuki, who became Prime Minister in April 1945, understood that Japan faced not military defeat, but potential extinction. The B-29 raids that followed Tokyo demonstrated that LeMay's tactics could be applied systematically to every Japanese city. Osaka, Nagoya, Kobe, Yokohama all experienced firestorm, raids that destroyed their urban cores. Smaller cities with populations of 100,000 or less were attacked in raids involving only 50 to 100 aircraft, yet the destruction was proportionally identical. The psychological impact on Japanese leadership was profound in ways that traditional military defeat could never achieve. Armies could be rebuilt, fleets replaced, lost territories recaptured, but cities filled with civilian populations could not be resurrected from ash. The B-29 raids were killing Japanese faster than they could be replaced, destroying housing faster than it could be rebuilt, incinerating industrial capacity faster than it could be relocated. Lieutenant General Kawabe, who had predicted this outcome months earlier, submitted increasingly desperate assessments to the Army High Command. His June 1945 memorandum contained statistics that amounted to a death sentence for the nation. Since March, B-29 raids have destroyed 66 cities, killed over 400,000 civilians, rendered 8 million homeless, and reduced industrial production by 57%. American bomber losses during this period: 143 aircraft, representing less than 2% of sorties flown. At current rates of destruction, Japan will cease to exist as an industrial nation by October. The final irony of Japanese miscalculation about the B-29's range became apparent during the closing weeks of the war. American engineers had developed modifications that extended the Superfortress's already remarkable endurance. Improved fuel management systems, refined aerodynamics, and upgraded engines increased combat radius to over 2,000 miles. This meant that B-29 seconds could attack targets throughout the Japanese Empire, from bases in the Marianas, China, India, or eventually Okinawa, creating a web of overlapping range circles that left no location safe from bombardment. Japanese forces in Manchuria, Korea, and Southeast Asia discovered that their distance from American bases provided no protection. The industrial facilities that Japan had built in occupied territories to escape bombing were themselves destroyed by aircraft that flew farther than Japanese planners had believed physically possible. The range that had seemed impossible in 1941 had become routine by 1945. The technological achievement represented by the B-29 program extended far beyond the aircraft itself. Boeing had constructed an integrated industrial system that could design, manufacture, and deploy strategic bombers faster than any enemy could build defenses against them. The United States produced over 3,800 Superfortresses during the war, each representing cutting-edge technology, mass-produced with automotive efficiency. The contrast with Japanese aircraft production revealed the fundamental asymmetry that doomed Japan from the war's beginning. While American factories were producing B-29 seconds by the hundreds, Japanese industry struggled to build fighters and bombers using hand-fitting techniques that made each aircraft slightly different from every other. Quality control in Japanese factories declined steadily as skilled workers were conscripted and replaced by inexperienced labor. By 1945, Japanese aircraft were suffering mechanical failures at rates that would have been unacceptable even in peacetime. The financial cost of the B-29 program totaled $3 billion, more than the Manhattan Project that developed atomic weapons. The expenditure was justified not just by the strategic results achieved, but by the demonstration that American industrial capacity could simultaneously fight wars across two oceans while developing technologies that redefined warfare itself. The Superfortress proved that the United States possessed not just greater resources than its enemies, but greater ability to transform resources into military power. The end came in August 1945, with atomic bombs delivered by specially modified B-29 seconds. The aircraft that dropped atomic weapons on Hiroshima and Nagasaki were variants of the same Superfortress that had firebombed Tokyo 6 months earlier. The atomic missions demonstrated the ultimate expression of strategic range. A single aircraft flying from Tinian could now destroy an entire city without requiring hundreds of bombers and thousands of incendiary clusters. Japanese commanders, who had spent 4 years calculating bomber ranges, defensive perimeters, and industrial capacity, confronted a final equation that made all previous mathematics irrelevant. A single B-29 carrying a single bomb could generate destruction equivalent to 1,667 aircraft, each carrying 10 tons of conventional ordnance. The range that had seemed impossible had become the delivery system for a weapon beyond comprehension. Emperor Hirohito's radio address announcing Japan's surrender on August 15, 1945, made oblique reference to the strategic bombing campaign without naming the B-29 specifically. The enemy has begun to employ a new and most cruel bomb, the power of which to do damage is indeed incalculable. Should we continue to fight, it would result in the ultimate collapse and obliteration of the Japanese nation. But the atomic bombs were merely the culmination of destruction that the B-29 had been inflicting for 11 months. The Superfortress had proved that modern warfare would be decided not by courage or martial spirit, but by industrial capacity translated into technological superiority. Japanese commanders had miscalculated the B-29's range by underestimating American engineering, industrial power, and willingness to commit resources to strategic bombing. That miscalculation cost Japan everything. Today, the B-29 Superfortress is remembered as the aircraft that ended World War II in the Pacific. But its true legacy extends beyond individual missions or even the atomic attacks. The Superfortress demonstrated that distance no longer provided protection against industrial powers capable of projecting force across oceans. It proved that defensive perimeters were meaningless against strategic bombers that could fly over, around, or through any defensive line. Most profoundly, the B-29 revealed that modern warfare had become a contest of industrial systems rather than military forces. The nation that could design, build, and deploy the most advanced weapons in the largest quantities would dominate conflicts, regardless of traditional military virtues. Japan's warriors possessed courage, discipline, and fighting spirit that matched any force in history. But courage could not overcome an aircraft that flew farther than they believed possible, carried more bombs than they thought survivable, and arrived in numbers their industry could never match. The wreckage of Japanese cities, photographed by B-29 reconnaissance aircraft after the surrender, showed the ultimate result of strategic miscalculation. Where urban centers had stood, only ash remained. Where factories had produced war materials, only rubble marked their locations. The destruction was so complete that American occupation forces required aerial photography to identify what had existed before the bombing campaigns began. Japanese military records captured after the war revealed the extent to which commanders had understood their situation while remaining powerless to change it. Staff journals from Imperial General Headquarters documented the steady degradation of Japan's defensive capabilities. Fighter production falling, fuel supplies exhausted, pilot training reduced to weeks instead of years, anti-aircraft ammunition rationed to a few rounds per gun per raid. One entry from July 1945 captured the despair that had replaced the confidence of 1941. The B-29 seconds come every night now. Our fighters cannot reach them. Our guns cannot hit them. Our cities burn one after another. We calculated that America's bombers could not fly this far, carry this much, come this often. We were wrong about everything. The final accounting of the B-29's impact on Japan's war-making capacity demonstrated why range, more than any other characteristic, determined strategic bombing's effectiveness. From March through August 1945, B-29 raids destroyed 178 square miles of urban area across 67 cities. Industrial production declined by 67%. Transportation infrastructure was so thoroughly disrupted that food distribution to major cities became impossible, creating famine conditions even before the surrender. The human cost totaled approximately 400,000 Japanese killed by conventional bombing, with another 200,000 dead from the atomic attacks. Over 8 million were rendered homeless. The psychological trauma extended across the entire population, creating a collective experience of helplessness that shaped Japanese culture for generations. American casualties from B-29 operations totaled approximately 4,000 aircrew killed, a ratio of 100 Japanese deaths for every American lost. The statistics reduced the war's final phase to mathematics that no military tradition could overcome. American industrial capacity could produce B-29 seconds faster than Japan could destroy them, deliver ordnance in quantities that overwhelmed any defense, and sustain operations indefinitely while Japan's resources collapsed under blockade and bombardment. The lessons learned from the B-29's demonstration of strategic range influenced military planning throughout the Cold War and beyond. The recognition that distance no longer protected nations from attack drove the development of intercontinental ballistic missiles, nuclear submarines, and eventually precision-guided munitions that could strike targets anywhere on Earth. The Superfortress proved that future conflicts would be won by nations capable of projecting power across global distances, making geographic isolation obsolete as a defensive strategy. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now and don't forget to subscribe.